Content. So, good morning, everyone. This is one more Athena talk. I appreciate your participation. I know that it's like a little bit different than the topics of nanotechnology and engineering, but also is an engineering miracle, what they are trying to do. And this is how the community has introduced this technology, I think, something right before 25 years that the MIT first introduced this idea of offshore wind turbines as a source, as a way to exploit and leverage renewable energy sources, in this case, wind. Is an approach that if you have ever traveled in Copenhagen, try to observe when the aircraft is trying to land, and you will see that outside of Copenhagen, the whole sea is full of wind turbines. So these are wind turbines offshore. So they exploit some parameters that Teresa will share with us in order to have more renewable energy sources using also this kind of approach. A few words now about our speaker today. Let me also admit some people. So it's a pleasure that Teresa also is a very good friend. So Teresa Nogueira got her master's degree in electrical and computer engineering from the University of Porto, Faculty of Engineering. She completed her PhD in 2008 in the same field. Since 1994, Teresa has been a professor at the Polytechnic Institute of Porto, School of Engineering. I have to say that School of Engineering in Porto, otherwise ISEP, is like it's a very old school in Europe, something like 1800s. It was like the first day of its establishment. She's a researcher at the Center of Innovation in Engineering and Industrial Technology, CIETI, a research group from Politecnico do Porto. Teresa has served as the course director for the master program in electrical engineering power systems and was the vice director of the Department of Electrical Engineering at ICE. Her scientific research and publication focuses on renewables energy sources, energy efficiency, natural gas system, energy quality, the electricity market, distributed generation, and engineering education. She has an experience working as an electrical engineer in the industrial company, where she was involved in designing and constructing power transformers. Today's talk is entitled Sea of Change, the role of offshore energy in Southern Europe's future. I'm very curious to learn why only Southern Europe. But I will give the floor to Teresa. Teresa, I would like to thank you very, very much for your contribution. The students, our students here, and our students mainly, are here in order to follow the structure of your presentation, the motivation of your input, how do you justify your claims, and then how do you respond to the question. So it's much more than a research topic. It's also a training topic for us. Thank you very much, and the floor is yours. Thank you.
Thank you very much, Kostas. Good morning from Portugal to everyone in Greece or other corner of the world. Special thanks to Constantino Petritis for this kind invitation, and congratulations to Athena Colloquial Talks for continuing this initiative. Yes, my name is Teresa Nogueira, and I'm pleased here to share this issue that we are currently studying and developing, the role of offshore energy in South Europe. This study is a part of a European project, ShoreWinner, Southern European Community for Offshore Wind Energy, which involves 22 partners from 5 countries: Greece, Italy, Portugal, and Spain and Cyprus. The project aims to establish a community of practice, our COP, focused on offshore renewable energy. This community will be a collaborative platform among our Southern European countries, and I'm going to ask why this focus in these Southern European countries. Our COP aims to create new learning resources and vocational education and training programs that ensure high-quality training to upskill and reskill the workforce. And before I'm going to talk, of course, about offshore industry, some context for this issue. As you all know, all European countries, all the countries from the world are currently transitioning from fossil fuels to renewable energy sources. While this shift appears beneficial and logical to the public, we cannot just simply replace every fossil fuel power plant with land-based or onshore renewable facilities. This approach is not a realistic solution due to the significant land limitations, including the capacity to be installed. I just cannot just replace any thermal power plant with some specific capacity by another renewable power plant with the same capacity, because the renewable power plant will take much more space, much more area. And this is a limitation. We are in Portugal, we are a small country, so we don't have so much land available to build the renewable power plants. Another issue from the renewables is the dam problem of intermittency. This is a challenge for the power renewable facilities. So it is very important to find realistic and practical solutions to address these issues. The offshore renewable energy can overcome those problems, those onshore problems. The sea provides ample space to build power plant of any capacity, and the energy is clean, renewable, and we can say it's limitless. So offshore renewable energy is becoming the most promising and reliable way to generate electricity. This is why Europe is investing a lot in this sector, and our project focus on that issue. The project Shorewinner also aims to address the intermittency in offshore energies by analyzing the potential of hybrid system based on wind, waves, tidal, and floating photovoltaic panels on the sea. However, this offshore industry is particular and it is demanding. It requires a specialized workforce with the necessary skills. VET programs from Shorewinner can help in professional development, which are crucial for creating a skilled workforce. With those VET programs, I don't mean programs only for energy technology, but all marine-related issues such as maritime safety, security, rescue operations, maritime cables, ports, infrastructures, and much more, according to what each country's expertise can provide for our community. And now, why the South? Why the Southern European countries, especially these our 5 countries? The offshore energy industry in these our five Southern European countries is still in its early stages and requires further development. Compared to northern regions, we are still in the process of establishing our offshore sector. We all have the sea in front of us. The Mediterranean Sea has a vast offshore potential. We need to focus on developing skills by elaborating training programs and VET curricula aligned with the offshore industry needs. So the Shorewinner presents an opportunity to contribute to developing the sector in our emergent industry countries. But planning an offshore power plant requires a multidisciplinary approach, integrating technical, environmental, and logistical considerations. Here I'm presenting mainly 3 main key actions for it. And now starting with the sea mapping. Analyzing sea area mapping, it's the first step for any offshore project because every sovereign state can only use its maritime resources within its exclusive economic zone. This EEZ, exclusive economic zone, for each country, it defines its maritime territory. In this map, as you can see, this map shows each country's exclusive rights and permissions to exploit energy resources from water and from the wind. The sea areas surrounding each country and its islands are designated as their EEZ, as prescribed by the United Nations Convention on the Law of the Sea. And if you look at this map, maybe you can think that the largest EEZ, the largest exclusive economic zones in the world, maybe you can think it's from United States or Brazil or Australia, but they are not the number one. Maybe you can be surprised, but the largest EEZ zone in the world, it belongs to France. France, they have EEZ zones in the north and in the south, yes, but there are lots of French islands. So number one in the world, the largest EEZ belongs to France, and number two is United States, number three is Australia, and Brazil is number 10. And I think most of you here are from Greece. So the Greek EEZ, I can tell you, is ranks 7th in the European unit and the 53rd in the world globally. And Portugal is a small country, yes, but we have lots of sea in front of us, so we are the 20th in the world. Each country with its own EEZ, its own exclusive economic zone, can explore its resources with the support of this very important tool, EMO-DNet. This EMO-DNet bathymetry can provide digital terrain model for the European sea regions. The EMO-DNet is a valuable tool for marine science applications, sustainable ocean governance, blue economy activities. So this is an application that includes planning, pipeline routes, locating offshore wind farms, and designing harbor extension. You can see here some results from EMO-DNet. The current analysis of European waters within the exclusive economic zone has identified many potential sites for offshore wind farm development. These sites here, as you can see in this picture, they are characterized by depths, shallower water, high wind speeds, and proximity to land grid connections, making them promising for offshore wind energy's future. While many sites are still in the planning stages, several offshore wind farms have already been constructed, they are operational, and as you can see here in these green points, some of them are already dismantled. So this is not a very, very new industry. As you can see here on this picture, this ongoing development highlights a significant difference in the progress made by Northern and Southern European countries in offshore wind energy. So After the geographic information system, after the sea mapping, after that very important step, we can understand the attractiveness of each zone based on costs. We can model each zone using the right site parameters for development zones identified. We can have some detail here for our Southern European countries. We know the Mediterranean Sea as yes, it's vast potential, but it is too much crowded anyway. All in the middle, in this area from Italy, EEZ, we can see these red points, these red areas, which are now focused they are in this zone to develop lots of offshore projects. These red perimeters here impact some issues, of course. It is important to focus on them because do some very important variables or issues. The anchor type, I don't know if it is possible to switch off these participants. Fabian, Ezema, if it is possible, please to switch off your sound. Thank you. The anchor type is a very important issue. Anchor type reflects seabed conditions. If we have gravel seabed, it requires piles, while sand may use drag embedded. The mooring cables, the mooring line length and diameter reflects bathymetry, met ocean conditions, and turbine size based on estimated force on the structure. Vessel operations. Sorry, Fabian, if you are here, please, if possible, turn on your sound, please. Vessel operations for installation and operation and maintenance. Vessel operations, yes, are impacted by distance to the port, and it is a very important issue when we analyze these very specific places. And the transmission system is driven by distance to land, to shore, impacting cable costs and electrical losses. So operation and maintenance, vessels, ocean conditions, distance from ports, all that details, all that issues for sure are strategic. They reflect economic choice for any offshore project size. So after the first step, so analyzing, identifying the areas, we can go to another very important key action, which I'm calling it number 2. There are lots of them, of course. Deployment analysis is a critical key action as it verifies the wind farm's technical and financial feasibility while facilitating a smooth installation process. As you can see here in this picture, it shows major components for an offshore wind farm facility. And there are lots of issues that we must think about it, but I will provide a brief overview of wind turbine foundation, this topic, and the electrical infrastructure, which is very important, of course, required to transport electricity generated at sea to the land. And about the foundations, I can say the foundation for these offshore turbines, the main difference between onshore and offshore wind turbines is their foundation design. Yes, onshore turbines located on land use a heavy reinforced concrete pad anchored in the ground. Offshore turbines face much more complex challenges. each requiring a specific solution. We must account for factors such as the weight and the height of the turbine tower, the characteristics of the seabed, the water depth, the storm conditions. So when selecting a foundation, we have available some technical options, but we usually organize all the technology into main groups. One is this, in this picture from the left side here, is fixed bottom option, such as monopiles and jackets. This technology, this fixed bottom technology, is suitable for depths of less than 60 meters. Another option is the floating offshore platforms. We use that kind of technology, this floating technology, for depths greater than 60 meters. And between these two main groups, we have, as you can see here, lots of technology solutions for these offshore wind foundations. About the cost, this is always, yes, our strategy is the cost. The cost structures of floating and bottom fixed offshore wind turbine differ significantly. Yes. Here you can see the CapEx, the capital expenditure cost for both technologies. The floating offshore wind turbines, the cost for floating, the cost of the foundations and its installation make up much of the total expenses compared to the bottom fixed installation. In absolute terms, the price per installed megawatt for bottom fixed foundations is about 1/3 of the foundation cost for floating technology. Therefore, these high expenses associated with floating foundations currently drive the costs of floating offshore projects for wind energy. However, while floating technology is more expensive and complex, it also provides opportunities for economies of scale, which could lead to substantial cost reduction in the future. To align with renewable energy goals and address the spatial limitations of bottom fixed offshore wind, Europe must create market conditions that promote the development of the floating. The floating technology is much more flexible. We can use in every situation, every cases. So while bottom fixed technology is less expensive, yes, it can only be used in shallow waters. In contrast, floating technology is more versatile, is more suitable for any kind of sea depth. So to reduce costs, it is necessary to improve all value chain procedures and significantly increase equipment suppliers' capacity. Currently, floating wind projects rely on suppliers from adjacent value chain as the bottom fix or even from the oil or natural gas platforms. So producing floating foundation will require a specialized value chain to achieve the necessary scale. So floating project must be rapidly scaled to create efficient infrastructures and foster skills development. According to DNV, this company consulting from Denmark, according to them, the current levelized costs of energy, LCOE, for floating now is about 250 euros per unit of energy per megawatt hour. This is more than 3 times the current LCOE for bottom fixed, which is about 74 euro per megawatt hour. Levelized cost of energy, this LCOE that I'm talking about, it is a very important economic parameter. Yes, it's defined as the revenue required from any source to achieve a rate of return on investment that matches the discount rate. So it is also known as the weighted average cost of capital over the lifespan of a wind farm. In simple terms, this LCOE represents the average energy costs produced through the project's lifetime, expressed in today's price. So, I can summarize in these 3 main tasks which are vital to unlock the potential for offshore. For sure, it will be the future of the offshore industry. We must accelerate the technology development for this floating offshore wind. We need a specialized value chain and a sufficient scale, of course, to ensure efficient development. In this picture, you can see standard layouts of an offshore wind farm and its key components. As you can see here, these are the wind turbine generators. Here, the electricity cable, everything is under the water, yes. The offshore substation, a very important component, and the connection to onshore power grid. So this is a different views of the same wind farm, offshore wind farm, as you may see. About this offshore substation, I'm talking something like this. A typical offshore wind farm can generate about 1 gigawatt of power, which is equivalent to the output of 1 or 2 standard nuclear power plants. Offshore substations are essential, yes, for reducing electrical losses by increasing the voltage on the sea, and in some cases to converting alternating current to direct current. Typically, an high voltage alternated current substation, offshore substation, is about 25 meters above the sea level, and it covers an area of about 800 square meters. A single substation can generally support an input of around 500 megawatt. If anyone wants to make me a stop, feel free to do it. It's okay. About the dynamic subsea power cables, another very important issue, yes, of course, for offshore energy projects. Actually, those involving floating wind farms or other marine renewable energy systems that are not fixed in place. So these cables transport electrical power from offshore facilities to onshore grids or between offshore installations. They are crucial to the system. Without them, the transmission of generated renewable electricity will not be possible at all. So, fixed or floating, a typical commercial scale offshore wind farm consists of an inter-array cable here connecting the turbines to an offshore substation here, and export cables connecting the offshore substation to the shore. It's more or less this standard, yes. layout. And now, the last one, key action 3, workforce capability requirements. Well, the sea presents many natural and human-induced dangers, making it one of the most challenging environments to work in. To ensure safety and operational success this demanding industry, training professionals for offshore work is very, very important. Working on the sea requires specific skills such as assembling equipment in the water, navigating, maintaining safety in high-risk conditions. So our Shorewinner project has a vital mission, establishing and developing a community of practice, our COP focus on offshore renewable energy. This community of practice aims to create new learning resources and vet programs. These initiatives designed to enhance job prospects for our learners and offer lifelong learning opportunities in the offshore sector. I hope it will promise a brighter future for the industry in the Southern Europe. And what we have developed so far, Shorewinner project began about 9 months before. And at this time, we are organized in 5 coves, 5 centers of vocational excellence. And for now, we are trying to understand the needs and trends for each national European offshore sector in these 5 countries. We develop surveys to teachers, students, and professionals in this area, and we are trying to identify the problems, the gaps that exist in this industry for each country. And we have this is the results now from Portugal. We have already results from the 5 countries, but we haven't yet finished our report that we are going to share soon. And when we ask the professionals in this specific industry, they said that there are really gaps in engineering in general, in project management skills and digital competencies, which are very important for this industry. They say it is not easy at all to recruit employees. Most of them, they are not any specific skills in that area. It's really hard to find someone with this expertise. About students, most of the students are very interested. They would like to learn, to get more knowledge about the offshore industry, but they claim that there are not enough information, and all they can be informed about the offshore renewable energy, they take it from social networks. They also say that there are not enough professional training. They cannot find appropriate courses to learn everything related to offshore energy, renewable energy. About teachers, teachers complained that there are no practical training opportunities. They don't find simulators, neither virtual labs to teach and to train their students in this important and very close future industry that is developing a lot for the energy system. So these were the most noteworthy gaps that we can find, we have been find in this situation. So for us, our conclusion are the offshore renewable industry really requires a very specific skilled workforce. It's not easy to we can install photovoltaic panels nowadays in everywhere, but it's not the same to install onshore and to install offshore. So professionals find it difficult to recruit specialized employees for this very specific industry. There are really gaps in training opportunity to learn to get more of this knowledge. So we believe that VET courses can foster a workforce aligned with the industry needs. So the enhanced VET, we believe we can strengthen the offshore industry and support its sustainable growth. And my final slide is some recommendations, and that recommendations not they are based on the English market recommendations, because England, United Kingdom, they were not the first country in Europe that built offshore power plant. It was Denmark, yes, but at this moment they developed so much. Their offshore industry now, we can say it is mature now, and their recommendations from the English people, they say, for education, how should we organize that? They think they think a modular approach is more achievable. It is not necessary to redesign the conventional courses, but the primarily study focus on electrical and mechanical engineering. They go from the academy to catch these people in electrical and mechanical engineering. And what they say is we should include some specific modules in these conventional courses. For instance, high voltage dynamic cables could be a very important issue. We can develop these specific models, opening up new possibilities and avenues for learning. For industry, of course, there is a natural tendency to rely on hiring skilled workforce or workers from within the sector. However, employers must recognize the urgent need to become more effective and open to upskilling and reskilling employees across all these offshore industry sectors. Technical working groups and interface design groups led by industry prime contractors or developers may become increasingly common in developing these floating offshore wind project, which will be our next future for sure. And that's
Thank you.
it. Thank you very much. Because
Obrigada, Teresa. Obrigada.
De nada. I thank you all.
So, thank you very much for your presentation. I'm very
Um,
happy that already our students are engaged and they have questions. Hassan, I will read first the question from Emin, and then I will come back to you because it's on the chat. I hope that you have no disagreement. So the question from our colleague student Emil is the following: what are the effects of these offshore windmills on marine life and on the migrating birds? This is the first one.
This is a very good question. I'm a professor of energy, and I usually teach energy. And I always say to my students, maybe you are clever and a clever generation than my generation. Maybe you can try to generate electricity in the future without any kind of pollution. Uh, what can I say? Yes, at that specific place when we install any offshore wind project, we change, yes, the fishes, flukes, yes. How can I say? we don't want to burn fossil fuels, but it's not possible. Any kind of energy generation in some way cause some specific damage to the environment. But when we are talking about sea, we are talking about huge areas. Yeah. So yes, we can organize it. I cannot say there is any kind of pollution. Yeah.
I have to comment two things here. The question is very good. Second, and my comments are the following. I mean, even the wind turbines on ground, they face similar problems in Germany for a period. So the German government had to stop them because the frequency that what is the name of
The blades?
the blades, of the rotation of the blades, attracted some particular species of bats. So they have
Bats, yes.
a lot of deaths of the
Yeah.
sun, particularly species of bats, around the wind turbines. They solve it by changing the shape of the blades and by the rotation.
And
Um,
the bats and some birds, but the bats, they it's like a fatal attraction to the blades. I don't know
yes,
why their anatomy is something like that.
yes. And also, regarding the sea, I think that, we have to solve another impact. The effect of the climate change has elevated the temperature of the sea by few degrees, which, creates huge problems regarding the survival of the species there. So it's not the wind turbines that they will create, they will destabilize the balance that already has been destabilized by far by the climate change. So we need to work more about climate change, and I think wind turbines, they are offering something towards this target in order to solve a problem and not create a problem.
We
The
are not
second,
never, yeah, we are
yes,
never
please,
happy
Teresa.
about that. Yes, I'm sorry. We are not
Okay.
never happy about that. We have at the moment only one offshore wind turbine. It's in the north of Portugal, and it's about far from 18 kilometers far from the line. And there are some
So,
people that complain that want to look at it. It's really
so
beautiful, but
But Teresa, I have a question here that I will
yeah.
ask it later on because I would like to finish with a question from our dear students. So the other thing, the other question of our students is like, what happens to those wind turbines when they expire? I mean, what is the recycling, and
Yes.
how hard is the recycling of this facility?
Yes,
And
it's the
there is a
same.
third question
Yeah.
that I think that for me it's very beautiful construction, but for our students, why are they so ugly? Like, what can I say?
And what, the blades, the towers?
As a construction, I suspect as a construction.
There's lots of concrete. Yes, it is necessary because we need any wind turbine. The tower must be very good fixed and they must have mechanical strength to support, yes, the rotation of the blades. So we need lots of concrete and later to recycle all that equipment. Well, I can say it's more or less the same in a few years to recycle the equipment from photovoltaic panels. It will be hard at the same time. So what we'll do to throw it to the ocean and to the seabed? Well, we hope to develop a recycle industry in the next few years, but meanwhile, we know we cannot burn any fossil fuels. So what can I do? We should develop. Yeah, I believe maybe the industry of hydrogen or green hydrogen will develop, but it's not yet developing enough to support our energy needs. So this is a solution, a very good one, and that's only these offshore wind farms can really replace the thermal power plants, because we are now closing all the thermal power plants, but they work always as the base of our diagram. Without them, what should we have? The intermittency of the renewables, that is not good for us. They will not guarantee us a stable generation of energy. Um,
Thank
of
you.
course, I have some hands here. I don't know if
Yeah,
you
let me answer the question first to
you
the chat.
guys. Okay.
Yes. So we have a question from our student Halil, compared to the offshore, what will be the advantage and the downside of deploying renewables in uninhabitable onshore locations such as deserts, high altitude locations, and etc.? Good question.
Yes, we may think where there is space, we can build a wind farm, but it's not the situation at all, because there are, even if we have available space, we really have land limitations. But even if we have mountains or deserts, there are some specific places with potential for wind energy. It's not because I have there a space, I should build there a wind farm, because we need a range of wind speed which is, I can say, efficient to generate electricity. And if we build a wind park in the desert, well, I will say it's much better to maybe to build a solar power plant, because the wind park onshore, it needs some cleaning, some water. Sometimes we need to clean the blades. It is necessary some quantity of water that will be not so much available in desert. So not because we have space, we can build an efficient onshore wind farm. So there are some specific places with some meteorologic parameters that are really good and will make a good efficiency of this generation of electricity. So
There is a question now from Hassan. Hassan, the floor is yours, and then I will move on to the online question. Hassan?
So I
Hassan?
have already
Yeah.
typed my question because I have an internet connection. Can you read it from the
Okay, I
chat?
will go. Okay, I will go then to Jose first, because this is the series that I have. In a long-term scope, how are the turbines and all these devices disposed or innovated in an ecological way? I think that somehow you have already responded to this question. Am I right? Are there any regulations or considerations you could share with us? Thank you, Jose, for your question.
like any other power facility, we need the critical materials. And um, I teach renewables. I'm a professor teaching renewable energy, but I know there are a big problem here. We don't want fossil fuels, and some of the fossil fuels we import from other countries. So we are not completely we don't manage our own energy, and that is very true. But however, for the renewable power plants, we are dependent also in the critical materials. And I think it's amazing. The critical materials all over the planet, they are controlled. A big share of them are controlled by China. And that places in the world with raw or critical materials that are not in China land. They are in Africa, and they are also controlled and managed by Chinese. So we are not dependent in this future from the fossil fuels, but we are now getting dependent on the raw materials and the critical, yes, materials. So I don't know, is okay. The idea now is not to burn fossil fuels, because we really need to control the temperature of our planet. As you know, in the maximum we should not increase more than 2 degrees Celsius the temperature in our planet. So, okay, stopping burning fossil fuels and everything is possible, but not for sure to burn any more fossil fuels. Yes, that's the idea. Maybe your generation will teach us which is better, but for now, it's the political guide, is the political framework. It's renewables and renewables and renewables. So the sea will offer these big opportunities. Did I answer to your question? I hope so. There are more questions here, right?
I think Costas is busy, so I will ask my question. Mine was next. Okay, so I wanted to ask you about the payback period and IRR of these projects. And are these projects actually financially viable for a private company? And lastly, does EU have any financing or subsidized lending scheme to finance these projects and make it more attractive to the investors?
And if you notice, yes, the LCOA now, the value now for offshore, that price is for Europe, 250 euro per unit of energy or offshore is really very expensive at this moment in Europe because Americans, they are now in about 140, something like that. But if you remember, maybe you are too young or maybe you don't remember, but when we, about 20 or 30 years ago, when we began with the photovoltaic panels, the price per unit of energy, well, it was really very expensive too. Then we must begin, and at the beginning of this new industry, yes, of course, we must have some governmental support to develop and to get the industry more mature. Otherwise, we are not able, yes, but we know that all governments are guiding us to close all the thermal power plants. So, yes, we need some financial support at this beginning. But with the development of the supply chain, we need scale, as I talked to you, we need scale in this specific industry. After that, yes, for sure, the levelized cost of energy will decrease in the next coming years, for sure, yes.
Since we need to close, and I will have two more questions from Vasiliki Slavidou. Are every scale of windmills eligible to be developed on each country exclusive economic zone? Is large scale in favor of small ones? And if so, on what criteria based? Please, a very fast response on this because
Yeah,
we need to close.
the exclusive economic zone, well, it was decided in about 1982 or something like that by that conventional, yes, nations. But well, there is no discussion about that because Switzerland has no EE zone. Yes, but so for sure, this specific industry will develop in some countries with larger EEZ and less in the other countries. But we
These are
cannot do
political decisions as well. This is not
yeah,
something that you can give
no,
a
we can
specific.
control. If we have C, we will have opportunity. So we have larger EEZ, so we can manage it. If we don't have, I'm sorry about that, we should
So what
invest in other.
about is large scale in favor of small ones? And if so, on what criteria based? This is a good question.
Uh, if I understand the scale of all over the value chain, yes, this is too much necessary, yes, because now we are completely dependent on the materials coming from China. If we develop in Europe, if we can develop all that supply chain and get more suppliers, so for sure we can control our own industry and for sure develop economies of scale to decrease this price, this beginning
Also
price of.
depends, I suspect that this depends also on the area that you have an availability to develop such a thing. So in Aegean, that we have a lot of islands, probably the smaller scale is more attractive. And also this has
Yeah.
to do, what is the name of my colleague? Where she is? I lost her. No, Vasiliki. This has to do also with the agreements that we have and the disagreements that we have with Turkey regarding our economic exclusive zone. So it's like a tricky question, but very good question. But I think depends on also on other parameters, I
Yeah.
suspect.
And for you, I think all of you are students, right? Most of your students. For you students, young people, if you are really are interested in this industry, let me tell you, if you go to Germany, but to Taiwan, for instance, they are developing a lot this specific industry. They pay a lot for young people to work on this industry. Trust me, they pay a lot for young people.
Right.
If they develop some skills, try it. You will see Asia is developing all this industry.
Thank you very much, Teresa. We will appreciate to keep in contact with us and our students regarding these opportunities. I will write you a question about this COVE because I was in a COVE meeting now in Brussels before 2 days. So probably, I'm thinking to organize something about COVE. And I will ask you some questions about the COVE idea that I have in order to submit. So I would like to thank the students for their questions. It's the first time that I did not ask a question, and I like it very much that the students, they had their questions, and of course the colleagues like Vasiliki. Thank you very much also, Vasiliki, for your participation here. I would like to renew our date for Athena Talks next week. We are going to have someone who is going to speak about artificial intelligence in higher education. So we are living in this era, and I think it's going to be very interesting talk. Teresa, obrigada. Once again, thank you very much for your kindness,
you.
your smile, and your positiveness, and the content of your presentation. Thank you, and speak to you
I
soon.
thank you all. Yeah. It was
Bye.
my pleasure. Bye-bye. It was my
Greetings from
pleasure.
Lisbon. Bye. Bye,
Bye-bye, you
Tatiana.
all.
Bye.
Hello, Tatiana.
Bye.
Hi, hello, and bye. It was a nice talk, Teresa. I was not able to participate the whole time because of another meeting, but I like it. Thank you.
See you soon. See you, Costa, too.
Bye.
Thank you
Bye.
for this invitation. Bye-bye.
It's our honor. Bye.